hydroelectric power station. That means we use the natural force of water to make electricity. We're just going up this hill, and then coming into view on your left is our lovely 1960s concrete office block. This is where we house our professional tea drinkers or managers in there. And then directly in front of us we've got two spare super grid transformers that we got from a garage sale at Long Garnet when they were shutting down. Sat there ever since. 115 tonnes each they are. And obviously we're the ones doing any of the real work. And then this gate here, David's going to, if he can find his magic card, so there you go, there's the gate opening. This is the access tunnel into the power station. This is the only way you can get machinery or equipment in. It has to be stripped down so it can fit in here. As you can see, it's not very big. Notice a concrete liner here as we go in. That's just to give it a bit of added strength as we go under the main road, A85. And then same thing now as we go under the railway line. A couple of other places where there was a bit too much water coming in. The rest of it is all self-supporting black granite rock, the way it was left after the drilling and the blasting. This access tunnel, 14 feet high, 23 feet wide, about 4.5 metres by 7 metres, and we're travelling 3/4 of a mile, about a kilometre. Now, did you notice that we're going downhill? Yep, we started off at lock level, we're dropping down to sea level, so the power station is actually at sea level. That's a drop of about 120 feet, just under 40 metres. You might notice tunnels going off to the left in a wee second there for maintenance access. This one coming up here is for the tail race tunnel, and then further down another one for the tail race tunnel, and also the surge chamber. The water on the roadway, you can hear us splashing through puddles. That is rainwater that seeps through the ceiling from the mountainside, which is already high above us. The geologists have told us it takes 2 years to seep through and hit the roadway, so if you get dripped on when you're down here, it's 2-row rainwater. Squeezing past these vehicles, we're going to hit a drain channel. You'll feel a bump, that indicates we've dropped down to that sea level. So, and then you've got a small pipe on the right there on the roadway, that's for fresh water. The one on the left, we're just about to drive under, is for fresh air extraction. And then along with the ventilation shaft, which is in the transformer hall in front of you now, that just keeps the fresh air circulating throughout the power station area. So there you go, that's us in the middle of the mountain now, that being croaking high above your head, so just let everyone catch up here. Oh no, it's just leave it. And this tunnel's called the Right Hook. It's going to take us up to the top of the machine hall where the viewing gallery is. This side is spray concrete, that's just to keep you dry from that 2-row rainwater. It's all about customer service here at Cruachan. Then we've got the granite rock on that side after the drilling and the blasting. You might notice holes all over the place. Some of them have got broken drill bits in them, stuck in there after the gel ignite's gone by and slowly rusting away since the very early 1960s. This red apparatus here that the gentleman's working on, so a giant fire extinguisher for the power station. We call it an emulsifier system. It's got a large Clark diesel engine, 40,000 litres of water, designed to cover the power station in a fine mist. It's nearly 60 years old, gets tested twice a week. They've never had to use it. Let's keep our fingers crossed, we don't have to use it today.
Thank you.
This is showing you how they created this power station. The guys called it Tunnel Tigers. It was a nickname they had, tunnelling experts, originally from Donegal in Ireland. But by the time they got in here, joined by anybody who was willing to do this very dangerous work for huge amounts of money. So you drill a hole in there, 8 feet, 2.7 metres, pack it full of gel ignite. You'll see a guy connecting the cords together, run that to a detonator, find somewhere to hide and then just blast it. When the dust settles, shovel all the spoil into wagons, take it to the mouth of the tunnel, tip it into the lock. We just did 3/4 of a mile, about a kilometre. Took them 1 year to do the access tunnel, all solid granite, remember. 2.5 years to do the other tunnels in the caverns, they're massive caverns as well, and 2.5 years for the engineers to fit out the machines. Started in 59, had the place up and running by 65. If you were outside on this project in the early 60s, you'd be getting about a tenner a week, which was higher than the average in the area at the time. Tunnel Tigers, 12-hour shifts, danger money as well. You get about 100 a week if you were down here in the tunnel. If you Google it, this will come up. Gets updated every 15 minutes. Just gives you an idea of what everybody's been doing. The streams are 500
on the left there, halfway along, one floor up, can you see the windows sticking out of the wall? That's the production control room. There's 2 operators in there all the time in contact with the National Grid. Then we're looking over the machines. We've got 4 machines. Unit 4 is the one nearest us, the one that says Crook and the Hall of Mountain on it. And then behind that we've got units 3, 2 and 1. So run the 4 machines at the same time, 440 megawatts. That's enough power to run a city the size of Edinburgh, for example. And we could do it for 16 hours when the reservoir's full. It's not really a thing we do though. We are a rapid response power station designed to cover the peaks in demand. They're the starter motors. We call them Pony motors. They're 10,000 horsepower. You need that power to start the machine up. The penstock pipes go through the rock behind you and then go that way 55 degrees, about 1,300 feet or 400 metres to go under the wall of the dam. You've got about 40 bar of pressure behind this, so what you do is open it using hydraulics, this hydraulic ram here. So the water will come in, hit the turbine, disconnect the Pony motor now. All you're using is your high head water pressure. The water will go through the edge of the turbine here and it will come out the bottom into this pipe called a draft tube, taking the water round the corner past the minibus into the surge chamber to slow it down. And each machine uses 30 tonnes of water a second, so if you've got 4 machines generating 120 tonnes of water they're using every second, it's sped up to about 140 miles an hour. Can't just let that out to walk on, it would just blow everything away, so you need to slow it down first. Via then, that power goes on 6 oil-filled cables, so we're using oil cooling up that ventilation shaft onto the pylons and then away down to Glasgow onto the grid. And that's usually your high peaks. They're 650 tonnes each. Rotating parts in the middle are 250 tonnes. To give you a better idea of the size of them and the size of this machine hall, all had to be. Picture of the machine hall under construction, taken in early 1962. Where is Tunnel Tiger standing? He must have had a good head for heights, because from here to here is 127 feet, about 39 metres, 77 feet wide, about 23 metres, and from this wall where we're standing to the far wall beyond those yellow gantry cranes, there's 2 of them, that's 300 feet or 90 metres, and that's all drilled and blasted by the Tunnel Tigers. So they'll be making their way up this right hook, they'll create this level here. Next thing they'll do is install the concrete false ceiling. That's not load supporting, that's just keeping the machine hall dry. And then the machine hall floor, and we're looking down on, is going to be this level here, where this Land Rover is, roughly where we left the minibus. So you've got your Pony motors above the floor, underneath the floor is the generator unit, remember the magnets spinning sheets. So at the moment, these blades are lifting the water back out through the edge of the turbine. So let's imagine we can pick that up, turn it like that. It's going to be sitting here at the bottom of the machines, inside a spiral casing, turbine casing here. So your turbine's going to be there, with your lid on that. And then you've got your 60 tonne inlet valve that way, and then through the rock to the right are the penstock pipes. They're just about to be shoved in the holes, one for each of the 4 machines. Water goes in here, remember, 30 tonnes a second. October the 15th, 1965, the grand opening. My very young looking queen here, and this is a picture of 290 guests sitting on top of 20 feet or 6 metres of what looks like very quickly formed together scaffolding. And they have no idea that there is a massive drop there, because they're basically here to disguise the fact that they're still working on 3 and 4. So that platform's here with a massive drop down there. Everybody watched the Queen start up the power station with this very symbolic lever here that she pulled, obviously not attached to anything. There's a guy in the control room, he just puts a white coat on, presses a button on the desk, and that was it, up and running. Up in the mountainside there was a natural basin-shaped hollow known as a quarry. There's a concrete butcher's dam at this end, and that holds back 10 million tonnes of water. Underneath the water are 2 pipes called penstock pipes. They start off at 16 feet, 5 metres in diameter, concrete lined, and they run through the mountain towards the machines at a 55-degree angle. 3/4 of the way down they get chopped into 4, and then they get tapered down to 6 feet. They're now steel lined due to the pressure of the water. Connected to those are generator units making the electricity, which just goes straight to the UK National Grid. You need to slow it down via a large cavern called the surge chamber, which comes uphill from the power station and then exits to this area on the right. Now you call them pumps, and then all you do is pump the water from Lochaw back up to the reservoir exactly the same way as the water came out, and that's usually how it works.
black granite.
It's a type of granite called
There will be
Highline.
more renewables online, wind and solar. Requiring storage because they do tend to overproduce in between the peak times. So we'll pick that up and then just reverse pump to then store that energy up in that High Quarry Dam. This project, this original one that we've just seen, 6-year project, they did it 6 months ahead of schedule. It cost 24 million, $500,000 under budget, and they paid it back in 12 years. The new power station, 6-year project, starting budget is about 500 million. So my question to you is, do you think the new power station will be done under time and under budget?